back to A+ Maths. My name's Heidi Postle. Today I'm going to continue on with our functions and graphs, and we're going to concentrate and we're going to learn how to graph hyperbolas. So let's get started. Hyperbolas are a different type of graph because they come in the form y equals 1 on x. Now that's interesting because if you have x equals 0 on the denominator, then you have 1 over 0, which doesn't exist. It also means that you can't have y equals 0. Well, you can't have y equals 0 because 1 over something can never equal 0. We're going to have asymptotes at y equals 0 and x equals 0. Now your graph for y equals 1 on x will look like this. And your graph for y equals minus 1 on x will look like that. And don't forget that we have two asymptotes. That's where the graph can never equal. And those are going to be x equals 0 and y equals 0. Now that we've had a look at our basic curves, y equals minus 1 on x and y equals 1 on x, let's see if we can graph this one. Y equals 1 over x plus 1. So we have our basic curve, which is y equals 1 on x, and we know that the whole thing has to go up 1 plus 1, up 1. So we're going to start by drawing our basic curve of y equals 1 on x, just like we've done with all the other curves that we've been doing. So there we have y equals 1 over x. Don't forget to label your asymptotes, and your asymptotes are x equals 0 and y equals 0. We're not moving left or right, so that asymptote is going to stay the same. But we know that our whole graph has to go up 1. And when you have an asymptote, the asymptotes have to go up with it, or left and right with the graph. So because our graph is going up 1, our asymptote, which is y equals 0, also has to go up 1 to y equals 1. So our asymptotes are y equals 1 and x equals 0. You draw your asymptotes and then you draw your curve. Now when we're drawing a hyperbola, you should always label one point in each section of the hyperbola. And our hyperbola will always have two sections because it's got two asymptotes. You can pick any two numbers except for any x values that are on the asymptote. So in this case, we're going to pick x equals 2 and x equals minus 2. But of course, they're not a point until I have a y value. So I have to substitute the y value back into my original equation, y equals 1 on x plus 1. So I get y equals a half plus 1, which is 1 and a half. So I get my coordinates 2, 3 on 2. And then when I go x equals minus 2, I get y equals 1 over minus 2 plus 1, which is a half. And then I plot them on my graph. Now let's take a look at y equals 1 on x minus 2. So what do we have here? We have our basic curve, which is y equals 1 on x. And then we have minus 2, which tells us that the graph has to go down 2. Good. Do you see how these are related to the last ones? That all the graphs move around the same way? I hope so. So what's the first thing we need to do? We need to draw our y equals 1 on x. Looks like this. Everyone happy with that? Don't forget your asymptotes, x equals 0 and y equals 0. Now we need to find our new asymptotes. So what do we know? We know that y can't equal minus 2 because the whole graph goes down 2. And we know that x can't equal 0. So our asymptotes are going to be y equals minus 2 and x equals 0. So we've got our whole graph, y equals 1 on x, and it's gone down 2. And label your new asymptotes. Don't forget that before you're finished with a hyperbola, you need to find 2 points, one in each section. You're allowed to pick any x value as long as it's not on the asymptotes. So which 2 points should we pick this time? I'm going to pick x equals 2 and x equals minus 2. For no particular reason, just because they're small numbers. And now that I've decided which x values I'm going to pick, I need to actually make them a point. So I need to find the y value. And to find the y value, I need to sub it back into the original y equation. Y equals 1 on x minus 2. So I do that and I get y equals 1 over 2 minus 2. And you can work that out on your calculator or in your head. And you should get the coordinates 2, comma, minus 1.5. Then I substitute in x equals minus 2 to get the y value. And I get minus 2, comma, minus 2.5. And then of course I need to plot those points on my new graph. Let's say we have y equals minus 1 on x plus 2. What's this going to look like? Remember we have our basic curve, which is y equals minus 1 on x. And then we have the plus 2, which means that the whole graph goes up 2. Where do we start? Good. We need to draw our original basic curve, y equals minus 1 on x. There it is. X can't equal 0, so x equals 0 will be my vertical asymptote. Our horizontal asymptote goes up 2, so y can't equal 2. So my asymptotes are going to be y equals 2 and x equals 0. My whole graph has to go up 2. I draw my new graph and I've got my asymptotes labelled of x equals 0 and y equals 2. And of course we need to remember to label a point in each section, top right and bottom left. So we can pick any x values that are not on our asymptotes. So what points do you think might be good ones to pick this time? Remember, you can pick any x values. So if you pick different ones to me, that's fine. I'm just going to stick with x equals 2 and x equals minus 2. And of course, I need to sub those values back into the original y equals minus 1 on x plus 2 to get the point, the actual x comma y point, which is what I need to plot on my graph. So when x equals 2, y equals, sub it in, I get 1.5. So my point is 2 comma 1.5. And when x equals minus 2, I sub that back into my original equation and I get y equals 2.5. And so my point is minus 2 comma minus 2.5. And then I plot the 2 points in the right spot on my graph. Now let's get to one that's a little bit more tricky, where we're going to move it left and right and up and down. And I'm going to do this one slightly differently. I've still got my basic curve, which is y equals 1 over x. Except this time, I know that the graph is moved to there's a minus 1 attached to the x, so it's moved to the right 1. Good. Just like with parabolas and exponentials. And then I have my plus 2, which makes the whole graph go up 2. Moving these graphs around is a little bit more tricky than the normal ones, the easy ones where you're just going up and down. So this time what I'd like to do is I'm just going to move the asymptotes first. And then I'm going to put the graph in the right quadrants of where it's supposed to be. So let's have a look. I know that my asymptotes are supposed to be at x equals 0 and y equals 0. That's my basic curve. Except this time, the asymptotes, 2 asymptotes have moved because my graph has moved to the right and it's moved up. So I know that y can't equal 2 because the whole graph has gone up 2. And I know that the graph has moved to the right 1. I know that the denominator can't equal 0 because I can't have 1 over 0. So I know that x minus 1 can't equal 0. So x can't equal 1. So what are the asymptotes going to be? They are going to be y equals 2 and x equals 1. So I want to plot those asymptotes first. There's my dotted lines. I've plotted the asymptotes. Now I know that this graph is a y equals plus 1 on x. So I should know that my graph will go in the top right and bottom left-hand quadrants. And that's what the graph looks like. Now remember, what do we have to do when we're graphing a hyperbola? You should always label 2 points, one in the top right and one in the bottom left. I'm going to pick x equals 2 and x equals minus 2 like I always have. Sub it back into the y to get the y value, so I actually get my coordinates. So y will equal 1 over 2 minus 1 plus 2 equals 3. So my point is 2 comma 3. If I do x equals minus 2, my y is going to equal 1 over minus 2 minus 1 plus 2, which is 1 2/3. So my coordinates are -2, 1 2/3. Then I have to plot them on my graph. Now this one's interesting because actually, probably a better point for me to have picked is x equals 0. And if you can pick x equals 0 as one of your x coordinates, you should always do that. If I put in x equals 0 into my original equation, what do I get for y? Did you get 1? Good. So we can label 0, 1 on our graph as well. Next time, we'll look for that first. And when we pick our values of x, we're going to pick x equals 0 if we can. Let's take a look at this one. Y equals 3 over x plus 2 minus 1. So what have we got this time? This time, we have our basic curve y equals 3 over x plus 2. What does that tell us? Remember, that tells us that the actual graph is going to move plus 2 to the left. Good. Our graph goes left 2. Remember, the 3 at the top is going to make everything a little bit steeper. And then we have minus 1, which tells us that the graph goes down 1. But remember, because this is a hyperbola and we're moving it right or left and up and down, we're going to do the asymptotes first because that's going to make it easier to draw it in the long term. So we know that our basic graph has asymptotes at x equals 0 and y equals 0. We need to think about what are our new asymptotes going to be. Well, I like to think about the y1 first. I know the whole graph is going down 1. So I know that y can't equal minus 1. That's going to be my first asymptote. Now I've got the denominator, which is x plus 2. And remember that the denominator can't equal 0 because you're not allowed to have 1 over 0. So x plus 2 can't equal 0, which means that x can't equal minus 2. And that's going to be my vertical asymptote. So my two asymptotes will be, what's the equation of them? Y equals minus 1 and x equals minus 2. I'm going to draw my asymptotes first. Y equals minus 1 and x equals minus 2. Then I go back to my graph. It's y equals plus 3 over x plus 2. It's a plus hyperbola. So that means it goes in the top right and bottom left. And I draw my two sections. Now remember, whenever you draw a hyperbola, you have to label points, one in each section. And I can pick any x values I like. But remember our last graph? And I said to you that if you can pick x equals 0, you should. So this time we can, because x equals 0 is not one of our asymptotes. So I'm going to pick x equals 0 and x equals minus 4. And of course, I then have to sub those values back into the y, the equation for y, to get the coordinates of the points. So when x equals 0, I have y equals 3 over 0 plus 2 minus 1, which gives me a half. So my coordinates are 0, a half. When x equals negative 4, I sub that back into y and get minus 2 and a half. So my coordinates are negative 4, minus 2 and a half. And then I plot them on my graph. How are you finding that? Are they okay now? Let's have a look at another one to make sure that you're getting it. Don't forget, if you'd like to pause the video and try on your own, you should do that and then press play to see if you got it right. Here we have y equals minus 2 all over x plus 1 plus 3. So what do? We have our basic curve. Be careful, this time it's a minus. And what do we know about the graph? We know that it's got a plus 1 attached to the x. That means it's going to move left 1. And then we have our plus 3, which moves the whole graph up 3. We have our basic graph, which has asymptotes at x equals 0 and y equals 0. We want to think about our asymptotes first, remember? Did you do that? I hope so. Now we're going to think about our new asymptotes. What's our new graph going to have as its asymptotes? First we do the y. Our normal graph had y equals 0. This time our graph goes up 3. Our graph can't touch y equals 3. That means that the asymptote will be y equals 3. We know that y can't equal 3. Then we have a look at the denominator, which is x plus 1. And we know that x plus 1 can't equal 0 because it's on the denominator. So x can't equal minus 1. So what are my two asymptotes? Y equals 3 and x equals minus 1. So we come back to our graph and we're now going to just draw the asymptotes. Y equals 3 and x equals minus 1. Don't forget to label them. Remember that this time we have y equals minus our basic curve. So it's top left and bottom right. How are you finding these? Did you do this on your piece of paper? And did you remember to label points? Let's see if you got them right. So, label points, one in each section. Remember, it doesn't really matter which points you pick, but I'm going to pick x equals 0 because I can. And I'm going to pick x equals minus 2. If you've picked different numbers, that's fine as long as you've substituted them in correctly. And I need to find the y values of each of these x values to actually get the coordinates. So when x equals 0, y equals 1. So my coordinates are 0, 1. And when x equals minus 2, y equals 5. So my coordinates are minus 2, 5. And then I plot those on my graph. And just make sure that everything's in the right spot. Let's take a look. We have y equals x plus 2 all over x minus 1. Now this is very different because it doesn't look like a hyperbola, but we know that it's a hyperbola because it's got the x on the denominator. So what can we do to make this graph look like the ones that we've already done? Now this is really tricky because what I'm going to do is I'm going to create whatever's on the bottom on the top. So I'm going to rewrite this equation as y equals x minus 1 over x minus 1. Now I've got the same on the top and on the bottom. But what's my problem here is that I've now changed the question from being y equals x plus 2 over x minus 1 to y equals x minus 1 over x minus 1. But I'm not allowed to do that. So what do I need to do to the top to make it a plus 2? I can write that as x minus 1 plus 3 on the top, just like this. So now I have y equals x minus 1 plus 3 all over x minus 1. Now you've probably never seen anything like that happen before. It's a really good trick to know how to do. So now we can split it up into two fractions. You're used to putting things together and getting a common denominator. What you're probably not so used to doing is to splitting them apart. And that's what we're going to do. And we're going to get y equals x minus 1 over x minus 1 plus 3 over x minus 1. Can you see what I did? If you're finding this one really hard, that's all right. This is really a level 3 advanced question. So you can always skip forward to the next bit on circles if you'd like to. But for those of you who find this really interesting and a bit more of a challenge, you can keep watching. So now we have our split up fraction. You should now see that x minus 1 over x minus 1 is 1. So I can write it as y equals 1 plus 3 over x minus 1. And then I end up getting my original style of question, which is y equals 3 over x minus 1 plus 1. Well, that's really good, isn't it? Because now I've got the same curve as what I had before in all those previous questions. And this time I know that the graph is moved to the right one because it's x minus 1. And the graph goes plus 1, which is up 1. So I know that I'm going to have two new asymptotes. I'm going to have the graph has gone up 1, which means that y can't equal 1. So y equals 1 will be my asymptote. And I can have x minus 1 can't equal 0. So x equals 1 will be my other asymptote. So I label my two asymptotes on the graph, x equals 1 and y equals 1. And then I know that my graph is y equals plus 3 over x. So it's a positive hyperbola, and so it goes in the top right, bottom left. And of course, I need to label 2 points. And remember, you can label any points. So I'm going to label x equals 0, which gives me a y value of minus 2. And I'm going to pick x equals 2 and y equals 4. how did you find hyperbolas? Hopefully, by the end of this, you will have understood what to do when you get a hyperbola. Remember, the hyperbola is easy to spot. It's always got an x on the denominator, so make sure you look out for that. And that brings us to the end of hyperbolas. Hopefully, you're starting to see how the graphs all move around and how that they are very similar in the way that they move left, right, up and down. Don't forget that if your graph has an asymptote, your basic curve has an asymptote, then your asymptotes will move around with your graph. I hope you've enjoyed the video. See you soon. Don't forget to like and subscribe and press the notification bell if you want to get a notification every time I put out a new video. Bye!